Hi everyone, welcome to my YouTube channel. In today's video, we'll be exploring how to perform a static routing in Juniper router, and this is part of the JNCIA Lab playlist. So what we are going to do is we'll be creating a loopback in two routers and use the static host to achieve the reachability, and we'll verify the show output command. Let's see, this is the topology that we are going to use, and you can see that R1 and R2 will only use these two routers as part of the lab. So you can see that both are connected via Ethernet 1. So let me quickly log into the routers. As you can see, I already did SSH. In the last video, we did configuration for the interface gig 0/0/0. Let's verify it. Yes. You can see that both routers are they are part of the same subnet. What I'm going to do, I'm going to create a loopback interface. For that, I'm going to enter into the configuration mode. For that, I'm going to use set interface loopback 0. So here you need to use a unit, right? Instead, you can use a unit or you can give with dot 0. Then family. So we are going to use the IPv4 address. Let's see, I will give the subnet as 1.0.0.1/32, right? Then I will perform the commit. I'll do the same in the R2 router as well. Instead of configure, I'll perform the edit. So I'm trying to maximum like to use the different commands that are used to achieve the same output. So I can use show pipe compare to see what all I'm adding. Yes. So I can check commit, check whether the syntax is correct. Yes. Then I'm giving commit. Okay. Now what I'm going to do, I'm going to verify the routing table between this R1 and R2, whether it has a reachability or not. So two way you can execute the operation command from the running mode, running configuration mode. So for that you have to use a run, then show route. Okay, here you can see, let's explore more on the routing table. In Juniper, you have like inet.0 and inet.6, right? Where you can see that best route will be placed in this routing table. They have separate routing table for multicast as well, for VPN as well. Whenever we enable the protocols, that will be they will be creating a inet.vpn for L3 VPN routes and RSVP and everything. So for now, we have enabled only the IPv4 routing. So that's why in default, it will only show the inet.0 and inet.6. So here you can see it's 2.0.0 is my local, and FXP you can ignore. See, you can see in the gig 0/0/0, I have like directly connected, and the next hop also is available here. But you see, I don't have the IP address or the route for the R1 loopback. So for that, what I'm going to do, I'm going to install a static route here in the route in the R1 as well as to R2 pointing to R1 loopback. So for that to do it, you have to enter into set. So it's under the routing option, static route. What is the loopback IP? 2.0.0.1/32. Next hop will be, so you need to, so there is an option in next, you can give next hop table. So, or next hop IP address. So I'm giving next hop IP address is 192.168.1.2. Okay. So show compare, it will give you the addition, right? So what I'm going to do, I'm going to commit it. So exit, show route. So there is one more option to view the protocol separately. Show route protocol. So this will help you to you if you want to filter the routes based on the protocols, individual protocols. So you can use this command. Static. Here you can see I have configured the static route, right? You can see that there is only one static route is available. So in case if you have OSPF or ISIS or BGP, you can use show route protocol. Then you can give the dynamic protocol name OSPF or ISIS. It will display all the routes that is installed on the routing table based on the IGP or the BGP. So this is actually helpful when you are running like more than one protocol and you want to see like which protocol route is installed in the routing table. You can usually use this command to explore it. Okay, what I'm going to do, I'll log into R2. So here I don't have the routing table, right? For the return route. So what I'm going to monitor traffic interface gig 0/0/0 dot 0. Okay. And now I will, what I'm doing is basically I'm monitoring the interface gig 0/0/0. So ping 2.0.0.1 source 1.0.0.1. Okay. So now if I ping and then let's see here it is showing that who has this, right? It is only getting the R, right? But it's not having, it's the routing is not reaching. Okay, let me say show IP route. Sorry, show route. Okay, so what I'm going to do, let me ping the same IP 2.0.0.1 source of 192.168.1.1. Now here you can see the ping is successful because okay, this is not helping me. Maybe I'll close this. Maybe I'll come up with next video how to filter the ICMP packets. So here you can see it is pingable. Why it is pingable? Because the router R1 and R2, they are the direct interface, right? Because I have the route table for 2.0, okay? And when it reaches the router R2, it has the route for 1.1, so it will reply. But in this case here, for this case, the ping will reach the R2, but R2 don't have the route for 1.0.0.1, so that's why we don't see any ping reply here. Okay, so to explore, it's okay. So to achieve the end-to-end loopback pinging, so what I'm going to do, I'm going to do a static route on R2 pointing to R2 and loopback. Okay, now let's verify the routing table. Okay, and now you see this is a static and this is a local. Now in both the routers they have the routing for each loopback. Now when I initiate the ping, yes, it is successful now because we have the route from R1 to R2 as well as the reverse route from R2 to R1. We have explored like the options like what all that we can check for the static routing, and I hope this video is helpful for you guys. If you like this video, do like, subscribe and share it with your friends. Thank you very much.